we may require to have a sub goals, or the main goal will be broken down into divided into sub goals. Then check for A combination in the knowledge base, because A and B are not available. Next one is we have to check for A combination with the help of Z. So Z is available here, so we have to get F and B, both the variables, to the database. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the chapter Knowledge Representation. So in this session, we are going to discuss about the concepts inference engine, forward chaining and backward chaining. Now let us start with the definition of inference engine. So you might have heard the word inference engine, as all of you know that it is a component of intelligent system in AI. So if you remember about KBA, knowledge based agent, so one of the component is inference engine. So what is the function of it? Which applies logical rules to the knowledge base to infer a new information from the known fact. So this is the function of the inference engine. So it is going to apply the logical rules on the knowledge base. So knowledge base is the place, or it is a part of a component where it stores the facts or information. And so with the help of the known facts and with the help of the logical rules, it is going to infer or derive the solution or new information. That is the function of inference engine. Next, it was used in an expert system. So it was inference engine. It was a part of, or it is a part of expert systems. Now this inference engine, it proceeds in two modes or two directions, or we can say there are two different algorithms. One is forward chaining or backward chaining. These are the two methods or two algorithms where we can make use, where we are using inference engine. Now let us see what is forward chaining. So forward chaining is also known as forward deductions, another name, or forward reasoning method when using inference engine. Another name for this is forward deduction or forward reasoning. So it is a form of reasoning. This forward chaining, it is a form of reasoning which starts with the atomic sentence. Already we have learned in our previous sessions, atomic sentence is nothing but a simple sentence or a single statement. It can be a single statement or a sentence in the knowledge base, and applies rules, inference rules, and in the forward direction, and extract more data until the goal is reached. So it is a forward chaining because it is going to start from the in forward direction, start from the beginning, and is moving towards the goal node or to reach the goal node in a forward direction. And that is the definition of forward chaining. And this algorithm start from the known facts and triggers all rules whose premises are satisfied, and their conclusion is to the known fact. Now this inference engine or this forward chaining system is going to apply the logical rules to derive at the new solution or the new statement or the new sentence. So this process repeats until the problem is solved. So this is the definition of forward chaining. So it is a method, it is an algorithm where it is going to start from the root node or from the start point and moving towards the goal node in forward direction, and is going to apply different logical rules on the knowledge base to the known facts and derive at the new informations or new sentence. That is the definition of forward chaining. Now let us see what are the different properties of forward chaining. So here it is a down-up approach. It moves from bottom to top, or we say it is a bottom-up design, or we can say down-up approach. So because it has to start from the bottom of the program. It is a process of making conclusion based on known facts or data. and starting from the initial state and reaches the goal state. So it is going to start the algorithm or starting solving the problems from the initial state or from the starting point and moving towards the goal state. Its approach is also called as data driven, as we reach to the goal node using available data. So another name for this is called a data driven approach or data driven. So because with the help of this algorithm, we are going to solve the problem with the available data and we are going to extract the different reasoning. Finally, we are going to reach the goal. So this is the one of the properties of forward chaining, and it is commonly used in expert system, as we have seen in the first slide. These are clips, business, and production rule system. See, these are the different applications of forward chaining. In the next slide, we will see one of the problem or an example for forward chaining. Now let us see, this is a KB is a knowledge base. Here in the knowledge base, these are the rules given here. What are the rules here? If A and C, then F. If A and E, then G. If B, then E. And if G, it is then D. And AB is the database. See, this is knowledge base. Means what is the knowledge base? It consists of some information or the known fact. This is the knowledge base. And what is the problem is, so I have to prove that if A and B are true, then D is true. So I repeat, if A and B are true, then D is true. The meaning is that here D, if you look at the database, A and B is the database given here. So as of now, there are only two variables, A and B. So we have to bring the new element D to the database A. That is a problem. So that would be the goal of this example in this problem here. So how to start a solution for this? Now, before we going for this algorithm, see, we have to remember these rules are the information in the knowledge base. So accordingly, so first one is check for AB combination in the knowledge base and it is not available. Now look at the knowledge base for AB in combination. Remember that now as and now the database only A and B is there. Our goal is to bring D to the database. In that way, first one is we have to look at the A-B combination, A and B combination. So if you look at this, in the knowledge base, A, C is there, A and E, B and C. See, there is no combination of A and B. Then check for A combination in the knowledge base because A and B are not available. Next one is we have to check for A combination. In that way, if you look into A and C is then F, A and E then G. So here in rule number 1 and rule number 2, we can find combination A. So accordingly, knowledge it is also not available. So next, check for B combination in the knowledge base. So A is not, single A is not available. Now we go for B. So if you look at the B here, in the B combination, now if B, then E. So we have only one variable B and then E. In that way, so we have to bring E to the database B. So accordingly, we have to B implies E means we have to move E to the database E in AB. It is in AB. So now the database A, B and E. At this stage, we have included E to the database and which was having the variables A and B. Now in the next step, in the next slide, we will see, so we have to repeat the steps. A and E to G is matching with KB. So put G in database. Now look at the knowledge base. If you look at the knowledge base here, so in the knowledge base, we have A and E. So here A and C and A and E. So if you look at this A and E, this is the rule number 2. If there are A and E, we can bring G to the database. So accordingly, so A and E, we have to bring G to the database. So we have to put G in the database. So execute G in database. So here the concept is we have to execute the database so that G will be added to the database. So accordingly, variable G will be added to the database. Now there are 4 variables A, B, E and G. Now repeat the step for G implies D matching with the KB. So to execute D in database, so database we are going to add A, B, E, G and D. Now finally we have added we got G into the database. So earlier in the beginning of the program there was only A, B was there in the database. Now after the algorithm or after we applying forward chaining concept, here we have added or included A, B, E, G and D. So G is included. That is the goal of this example, a goal of the problem. So this is an example for forward chaining. Now in the next slide we will see what is backward chaining. So it is also known as backward deductions or backward reasoning. As we have seen, the forward chaining we used to say, or another name is forward deductions and forward reasoning. Similarly, for backward chaining, we say that it is also known as a backward deductions or backward reasoning. And it is a form of reasoning, another type of reasoning. It starts with a goal node or the goal and works backward. And backward chaining through rules to find the known fact that support the goal. So here we are going to find out, or we are going to start from the backward, from the last point. That is why it's called as backward chaining. And here it is known as top-down approach, whereas in forward chaining it is bottom-up or down-up approach, and this is top-down approach. It is based on modus ponens inference rule. And in backward chaining, the goal is broken into sub-goals or sub-goals to prove the facts are true. Here we are going to start from the goal node. So here we may require to have a sub-goals, or the main goal will be broken down into, divided into sub-goals. So that is the procedure. So that will finally we are going to prove the fact, the information in knowledge base. It is called a goal-driven approach. And as we have seen the forward chaining, it is a data-driven approach, and this is a goal-driven approach, as the list of goals decide which rules are selected and used. So now we can understand from the sentence what is the meaning of backward chaining here. So here, with the help of this approach, the list of goals decide which rules are selected to derive the new information or to the goals. And it is used in game theory. These are different applications. Automated theorem proving tools, inference engines, and proof assistants, and various AI applications. And it mostly used in a depth-first search algorithm, as we have learned in the previous session. See, these are all the different concepts of backward chaining. Now let us take an example here. So what is the goal of this? In the example, goal is to get Z in the database. So here, so what is the KB as a knowledge base? At the beginning, the one rule is that if F and B, then Z. If C and D, then F. And if A, then D. And AEBC is the database. So this is the facts, so knowledge base. As of now, we have AEBC are the variables in the knowledge base, and what the goal is to get the Z into the database. Now let us start working on this. Here, what the question is, we want Z, so the check in the fact Z is not present in, so check in the rules. Now the goal is to get the Z. So we have to check for the rules here in the knowledge base. So accordingly, in the rule 1, it is deriving Z by F and B. Now get F, B is already matching, so get only F. Now if you look at the rule number 1, in the rule number 1, if F and B, then Z. So already is a goal. So with the help of Z, so Z is available here, so we have to get F and B, both the variables, to the database, F and B. If you look at the database, as of now, we have only F and B is already available, E is there, and only we have to get F. According to rule 1, only we have to get F. So if you want F, so check the facts. F is not present, so check in the rules. At this stage, F is not available, we have to get F. But if you look at the rule number 2, if you want to get F, we must execute C and D. We have to execute C and D. So we have to get D, because if you look at the database here we have to get the F and we have to get C and D. C is already present here, because C and D, then only is possible to get F here. So because of that, we have our C's already in the database, so we have to get or derive D into the database. So accordingly, look into the steps here. So C is already matching, we have to get only D. So want D, so check in the fact D is not present, so we have to check in the rules once again. So again we have to check the next rule. So in rule 3, deriving D by A, and now we have to get A. So it is possible to get the D if it is A. If you look at the beginning, the rule, if A, then D. So based on this rule, we have to get A. So A is already matching in fact. Now as we have to execute this, we got D, we have to place D in the fact. So because already A is available, so we have to get the D, so we have to place the D into the database. Now the fact is that it's having A, E, B, C, D. So here, if you look at the beginning, database was only A, E, B, C was there, and the goal is to get Z. So how to get the Z, or if you want to get the Z, we need to have all the variables A, E, B, C. So this is an example for backward chaining algorithm. Next, in the next slide, we will see, so if you want to get a Z, that is a goal of this, we have to execute F first. First, you have to get the F. Then for getting F, we have to execute C and D. See, in the previous slide, we have looked at the reasoning part of all the rules. So now we have to execute one by one. So get Z. If you want to get Z, we have to get F first here. If you want to get F, we have to execute C and D as per the rule. And once the F, C and D is matching in database, now the database will be having A, E, B, C, D and F. So in the previous step, we got D here, A, E, B, C, D. In the next step, we have got even F in the database. Now we have to execute F and B, because as per the rules, if there is F and B, then Z. So accordingly, FB is matching database. So finally reaching to state Z. So we have to include Z, or we have to get Z into the database. So here A, E, B, C, D, F and Z. So finally we got Z is included. So if you look at the question, here question is, goal is to get Z into the database with the following facts or knowledge base. So finally we got the database, Z is included in the database. So this is the concept of backward chaining. Students, so far in this session, we have learned the definition of inference engine, functions of inference engine, and also the algorithms forward chaining and backward chaining. Let us continue our discussion in my next session. Thank you so much.